Hey everybody, welcome back. I am back to working on this Stihl BR600 backpack blower. I ended up getting in a used crank and piston assembly off of eBay a while back, and then I just didn't get back to this project. But since it's November now and I actually have quite a few leaves on the ground that I might be able to use this thing on before the next snowfall, I'd like to try and resurrect this thing. At the very least, I want to close out this this series. You know, a few people have been asking about, hey, did you ever fix this thing? Are you going to get back to it or whatever? And well, I started working on the Stihl chainsaw, the MS290 again. Ran into a snag there with a broken piston ring that I didn't expect to find. So I've got new piston and rings on order for that thing. So I decided, well, why don't I change gears and hop over to this thing. So I'm just using this flat X-Acto blade to get off the heavy deposits of this red sealant that they use. And then I'll use some acetone to clean off the remaining residue, because I got to get this really nice and clean. Also, I'm just going to go over the parts washer and probably just, actually, I might not even need the acetone. Might be able to just do this in the parts washer with a brush. We'll see. So for those of you who haven't been watching right along, in case you're wondering why the heck I still have the muffler on this thing, it's because I can't get it off. The screws that hold the muffler on are recessed down inside here, and they feel like they're really badly damaged, the heads on them. These screws here don't want to come out either. You know, ideally I'd like to open up that muffler and shake it out, because there's I can hear some big chunks of rust or carbon or something in there, but well, it is what it is. Down inside there it doesn't look that great, but you know, we're going to try and save this cylinder assembly, reuse it with the new to this unit piston and ring and crank shaft. So those of you who haven't been watching this series right along, just give you a quick look. Here's the old crank assembly. The reason why I had to buy it was because I accidentally snapped off this end in the process of trying to take off, I believe it was the impeller side. But I wasn't too upset about it after that ended up happening, because when I took this apart and looked at it, I realized that this had suffered a pretty catastrophic failure anyways. I think that bearing's toast. This bearing might be okay. But more importantly, the connecting rod, this is the wrist pin that went through the piston, and it actually has metal that has fused to the steel. So this thing's cooked. And the piston, I can't get my hand on it right now, but it also looked pretty bad. So and the seals were toast, and it actually almost looked like some of the goop that was in here that I couldn't figure out what the heck it was might have actually been stuff that like melted from the seals and flowed into the case. So anywho, we'll come back after I get this all cleaned up. Oh, got these in a while ago and never really checked them. I guess I should do that now. Well, definitely used. Oh, those bearings. Yeah, those bearings, you could spin them and they keep going and they're nice and quiet, as opposed to these, which this one you can only spin it part way and get stuck. Get that magnet off it. And this one, well, I guess that one seems okay. Doesn't matter though. More importantly, doesn't have the end broken off. He left the old seals on there. I bought new seals. And the wrist pin area, this bushing that's in here for the wrist pin, looks good. So So I guess I must have planned on reusing the piston on this. Oh no, there's the piston right there. Okay. Yeah, I was going to say the piston was junk. What the heck was I just... Oh, I don't know. I'm tired. It's getting late. Haven't eaten yet. Not too bad. Even included the wrist pin, which is good because the one I got is junk. But it looks like the clips are missing. Hopefully I still have those clips. Ah! Upon closer inspection, there's the clip right there. The other one's probably still in the piston. Alright. The seller had removed the piston assembly from the crankshaft in order to facilitate shipping it in a smaller package and wrapping it. So I ended up installing the wrist pin in the piston and the little clip. So I just wanted to point out that according to the service manual that I found online, when you insert this little clip, the gap in the clip needs to be oriented vertically. So in other words, you can have the gap either up here at the top or down here at the bottom. So that clip, when you install it, the gap in the clip needs to be oriented vertically. So you can either have the gap up here at the top like I do right now, or down here at the bottom. You don't want the clip on the side over here somewhere or on the side over here somewhere. Why that makes a difference, I don't know. Then the piston rings, okay, we've got a gap in each ring. Come on, focus. There we go. We've got a gap in each ring, right? Now, on the MS290 chainsaw piston, there are pins that locate where the gaps in the rings have to be for you. On this, you could have the rings, the gaps anywhere and install the piston. But the correct way to do it is to make sure that the two gaps are 120 degrees away from each other. Oh, and before I forget, when you're installing the piston on the connecting rod, this arrow seen right here needs to face the exhaust port. So 120 degrees apart from each other. So a circle is 360 degrees. 360 divided by 3 is 120. So basically just look at it as if you divide this into a pie with 3 equal slices. Just make sure the gap of one ring is offset from the other ring by 120 degrees. So my bottom ring's gap is here right now. Right here. Okay. So 120 would be here and 240 would be here. That's about right there. Next up, I'm going to put a coating of engine oil on the rings and the piston. And of course, pretty easy on the Formix. The gear has to be on the side to mesh with this gear, so. So I'm not going to worry about the orientation of this gear with the cam gear at this point during assembly. I'm gonna straighten out that timing after the fact by actually installing the cam gear after I have this all put back together. The reason why is because the position you put the crankshaft in is determined by actually having the flywheel on and aligning the flywheel with the ignition coil on the other side. So since I've got to have this all together to do that, I'm just going to take out the cam gear right now. To take the cam gear out, I have to first remove these followers. So if I pull this pin, it's a little tight. There we go. I can actually take that follower out and this follower out. Push rods. And now I can pull this pin and take the whole cam gear right out. So the new seals that I have are actually they're Chicago rawhide seals. They're CR 5808s is the part number. And what these are, they're a 15 by 25 by 5. What that means is it means that the bore size is 15 for a 15 millimeter shaft. The OD is for a 25 millimeter bore, and the thickness is 5 millimeters. They're actually a pretty common seal to find online. You can buy the genuine Stihl seals, but a lot of guys online said that they just buy oil seals of a good known brand, you know, good manufacturer, and that they've had good luck with those. There are cheap Chinese seals that you can get, I mean, that are like crazy, like less than $2 a piece. You can get the genuine Stihl ones, I think, for about $9 a piece on average online, and then maybe pay like $4 to ship a couple of them. So not terribly expensive, but I'm going with these Chicago rawhide seals. So they recommend putting a light film of grease on the shafts before installing the seals, but then they also recommend that you have a light film of the sealant on the outside of the seal when you install it into the housing. So I'm going to be real careful that I don't get grease on the outside, because then that might compromise my bond to the crankcase. I'll try and clean the excess off this shaft. All right. Now I want to install the flywheel. I got a little bit of, I got a clean paper towel now, and I've got a little bit of solvent on here, and I'm cleaning off the taper on the crankshaft, cleaning off any grease that might be on there from when I greased up those seals. And I don't want to use a lot of solvent because I don't want it to run down and damage the seal. Oh, I forgot. This is the nut that I broke off of the old crankshaft. It's still got the remains of the end of the threaded part in there. I gotta get that out because I didn't get the nut from the eBay seller with the used crankshaft. Oh, everything has to be difficult. So this is the nut, and the piece of the crankshaft is still in there, and the problem is it's hardened, so I can't drill it out. I already tried, and there's not enough to grab onto, so I think it's just going to be easier at this point for me to just procure a new nut. Of course, it's metric and it's a flange nut, so I don't have an extra one, so I'll have to pick that up. In the meantime, I could just temporarily install this on here so that I can line this up. So the deal with this is, so I got to get it on there so the keyway lines up. So you rotate this around, and there's a south and north pole marked on this thing, and there's a little, I don't know if there's a mark there or what, but well, there isn't really a mark. But what they do is they show in the manual, they show that if you rotate this so that the very edge right there lines up with that edge of the part, the metal part sticking out of the ignition coil there, or the magneto. In other words, here's the PDF file. You can download this for free online, which is great. So the idea is you have to have it right in that position, and then I'm going to just take this off so it doesn't get bumped and move. We come around to this side. It's interesting to note that when it's in that position, through these two oval shaped holes right here, you can actually see the bottom of the connecting rod where it connects to the crankshaft. It's like lined up in there perfectly. So then you take your cam gear with the lobe facing up, you put that in like that. Okay, and the two arrows are basically horizontal. There's actually a there's a line on the inside of the case right there, and there's one right there that those arrows are actually pointing at. So then you get the gear in there, you then pre-oil your pin and stick this in. Oh, before you put this in, you want to check this. I'll take it back out. You want to check this decompression button right here. See this little button right here? This little thing sticks up right there. That is the decompression lever. I can push it down and it springs back. If that's sticking, you want to replace the cam gear. The way that works is there's a little spring in here and there's a little weight. And what happens is when the engine's running, this spins fast enough that that weight will move that lever and make this thing be recessed in like it doesn't exist, like it's not there. But if your engine's cranking slowly when you go to start it, that weight, that spring keeps that pushed up, and it allows the valve to stay open just enough to give you some compression release to make it easier to pull start. That's all it is. Whoops, look at it, I'm doing that wrong already. Lobe facing up, arrows facing the whatchamacallits, like that. Got it? Good. Once we've got that installed, then we rotate the crankshaft so that the lobe faces down, like so. Now we can install the cam followers. So now I'm going to put these little cam followers on, and the way these are made, they overlap each other. So if you put them on wrong, you'll see that one of them doesn't ride on the cam correctly. So pretty easy to figure out how these go. I'm going to put just a little bit of oil on that shaft. Just like that. And the push rods. The easiest way for me to do the push rods is to take the valve cover off, the rocker cover up top here off, and drop them in from the top. I'm going to want to make sure that they're in their cups correctly anyways before I seal this back up, so I might as well do that now. Alright, I've got the push rods in. I'm sure that the bottoms of the rods are sitting in the cups like they should be, and the tops of the rods are sitting under the little domes in the rocker arms. And I rotated the crankshaft a couple times and made sure everything was, working smoothly, nothing was binding. Seems okay. I'm going to reset the clearance on these valves before I try and restart this thing. But for right now, that's good enough so that I can seal and install this cover. I am going to put just a little drop of oil on the actually, I'm not going to put a drop of oil. I was going to put a drop of oil on the ends of these pins, and then I realized they don't rotate. That's right. So the gear rotates on the pins, and I already oiled those. Okay. Overthinking it. You'd think replacing this nut wouldn't be such a hassle, but the problem is this nut is M8 with a 1.0 pitch. And what's unusual about that is that's not, it's, I guess what an old time machinist used to call a mongrel thread. When I used to go over and I'd say, hey, you got one of these, you got a nut or you got a bolt? And I'd have one, he'd you know, get all upset and say, when he couldn't find it in his normal stuff, and say, that's some kind of a mongrel thread. Well, anyways, this would be a mongrel thread because it's just not an easy off-the-shelf standard in a flange nut. I was able to find at my local auto parts store a self-locking nut of M8 1.0, so that's what I ended up going with. And then I also got a washer, since I figured I'm recreating a flange nut by using a washer and a nut. And I went with the self-locking nut only because, well, it's not ideal, you know. So I tightened it to the torque that was in the manual, so hopefully that's going to be okay. Some of you guys might think that's a bad idea, but it is what it is. So an M8 6mm, I'm sorry, M6 1.0, found that. Go figure. All right, enough about that. All right, so Stihl makes a special feeler gauge for setting the clearance on these. It's part number 41808936400. The reason why you can't use regular feeler gauges like you can get anywhere is because of the design of the rocker arm here. It's got two little metal pieces on the side that keep it from being able to move off of the top of the valve stem. Alright, so you've got to have a feeler gauge that's really narrow like that to fit in there. So the problem is I don't have any feeler gauges like that. So what I did was I looked in the manual here, and it tells me that the inlet and exhaust valves should both be set at the same thing, which is 0.10 millimeter plus or minus 0.02 millimeter, which means as long as it's between 0.08 and 0.12 millimeter of clearance, I should be good to go. If I convert the low limit of 0.08 millimeter to inches, I get 0.00314961, which is just a hair, a 10,000th over 3 thousandths. My first thought was, oh, I'll just use gauge pins, but my smallest gauge pin set only goes down to 10 thousandths. So even the smallest gauge pin, which is tiny, is too big for this. But what I did have is I have some 3 thousandths thick shim stock. Okay, so I took my scissors and I cut a thin little piece of it, and if I put it in there, there's actually enough clearance. There's more than enough clearance actually. So what I'm going to do is I'm going to close this down so that I've got a little bit of a drag on this, and then I'm just going to back that nut off a tiny bit, and the end result should give me something a little over 3 thousandths, which is close to the 0.08, and should put me right around that sweet spot of 0.10 millimeters. All right, just for giggles, I'm going to do a compression test. Too hard to do it that way. I'm just going to put my my drill on there with my little adapter I made for spinning these kind of engines. So, I mean, normally you want to do a compression test. You want to do a compression test with the throttle wide open. You can't get much more wide open than nothing on. Ooh. I'm gonna lose that.
Daddy,
Yeah.
it's supper.
Okay. Supper time. 80 pounds. And there is a compression release on there that I'm contending with too. Bet you I can get it to come up higher than that if I spin it faster. $115. Anybody remember what it was way back when I started this repair? I had compression back then. I remember thinking to myself, I don't understand why I can't get this thing to run when it's got compression and it's got spark. Well, we will see very soon whether or not I have done anything to improve the situation. I mean, I'm sure I have. Those seals were just completely cooked. Those crank seals. Then again, I thought I pretty much had this, thought I had a handle on what the heck was going on with that Stihl chainsaw, and that thing's giving me fits.